All right, guys. So we just finished doing the process for solving a system of three equations, okay? Taking it one step further, now can you look at a word problem, set up your equations, and solve it? Now, some of these you can probably do without having to set up a system of equations, but that's only because some of these will be nice numbers. Are you always guaranteed to get nice numbers? So is it going to be, it might be easy to guess if the solutions x, y, and z are like 3, 4, and 11, right? You can kind of guesstimate when it's nice even numbers. But a lot of times we're talking about money, in which case you might have an answer that's, $11.73, and the other answers are also kind of ugly, in which case it's not going to be quite as easy to guesstimate those. So I will always be wanting you guys to solve these by writing a system of equations to demonstrate the problem, and then solving that system. Whether or not you're able to guess it and check, I don't care. I'm going to want you to show me that you can do it efficiently through using a system of equations. Okay? Now this is kind of one of your more basic problems here. This word setup is not too difficult. Then I'm going to show you some trickier ones after this. Okay? So for this one, we are told the top 3 apple growers in the world, China, US, and Turkey, grew a total amount of 74 billion pounds of apples in the recent year. All right, China produced 44 billion pounds more than the combined production of the US and Turkey. The US produced twice as many pounds of apples as Turkey. And so we want to write a system of equations to represent this and then solve it algebraically to find the number of pounds of apples produced by each country. So what are my variables going to represent? The what? What about the countries? How many apples or how many pounds of apples? Good. So you really want to pay attention to what do your variables represent, okay? Make sure you've got that straight, especially when we're introducing cost into a problem as well. You want to pay attention to, do your variables talk about how many of the things or how much it costs, things like that. Okay, now for this one, we're going to have, let's say, we'll just use the variables to keep it easy. C for China, U for US, T for Turkey, okay? And we already know that's talking about the pounds of each. So that very first statement, when it says that they grew a total of 74 billion, what is your equation going to be in terms of the C, U, and T? What operation are we doing? Addition. Yeah, so you're going to have the pounds in China plus the pounds in the US plus the pounds in Turkey. Total should add up to 74. Now, am I going to write billion? Am I going to put all the zeros on there? No, just leave it as 74. I'll know that my answer is in terms of billion at the end. Okay? So that's one equation. I have 3 unknowns. So how many equations am I expecting? 3 equations is what I'm expecting. Okay? So let's keep on reading through our statement just one sentence at a time. We're told that China produces 44 billion more than the combined production of US and Turkey. Pay attention here. A lot of you guys will do this backwards. You'll have the right idea and you'll add it to the wrong side of the variable. So you know that you're going to be adding 44 somewhere, right? Where are you going to add on that 44? Right. So a lot of people, and let me just write up here what the mistake is that a lot of people will make. A lot of people will write China plus 44 equals U plus T. That's not quite right, right? Because the way that they're saying it is that we should be having 44 more than the sum. So the 44 additional should go on to the sum of U and T, right? So make sure that you don't make this mistake. This, adding the 44 right here, is the most common mistake. Okay? All right, so I'm going to erase that because that was wrong. And I'm going to put that China should equal the sum of the US and Turkey plus an additional 44. Okay? My last sentence tells me that the US produces twice as many pounds of apples as Turkey. Do I involve China in this at all? No. I'm just between the US and the Turkey. What operation am I doing when I say twice as many? Multiplication. Which one am I multiplying? Turkey. So it says the US produced twice as many pounds of apples as Turkey, right? So yeah, you want to double Turkey to get the US. So U equals 2 times T. Again, most common mistake on this one would either be doing addition instead of multiplication. If I was doing addition, it would say two more than. That's all it would say. Not twice as many, it would say they produce 2 more than, right? The other common mistake is putting the 2 on the u instead of the t. All right, so now we have a system of equations to solve. What is nice about this system? In terms of when I'm going to go ahead and solve this next. What's nice about it? I can just plug in 2t for u is probably the easiest way to go through this, right? You could plug c in if you wanted to, right? That would also work, but it's a little bit longer and more tedious. So what I'm going to do is use this u, and I'm going to plug it into these two guys. All right? So what is that going to give me? This equation right here is going to become c plus, instead of u, I'm plugging in 2t plus t equals 74. Okay, and then the other equation, let's see if I can find that one. This guy is going to become c equals, instead of plugging in u, I'm going to use the 2t plus t plus 44. What should I do in my next step? Combine like terms, and then you have to kind of think ahead. You're either going to solve this system of 2 variables because now we're down to just c and t. Okay, we're either going to solve this by elimination or substitution. What is it best set up for right now?
Substitution.
Why do you say substitution?
Because you can, I know, you can just multiply by a negative.
I would say it's set up for substitution, but why? Why would I say it's set up for substitution? You've got a c equals. You've already got one of your equations isolated, right? If you were going to do elimination, you could, but you'd end up having to move things around a little bit more. So this is actually well set for substitution. So yes, I'm going to combine my like terms, and I'm going to leave everything on the same sides that they are. So for the first equation, I'll have c plus 3t equals 74. For the second equation, I'm going to have c equals 3t plus 44. All right, so now what I'm going to do for my next step, what am I going to do now? Yep, we're going to take this quantity and plug it in for this c in this equation, and then I'll have an equation all in terms of t, right? So if I do that, I'm going to end up with 3t plus 44, that's plugging into this c right here, and then the rest of the equation is exactly what it was, so plus 3t equals 74. And now I just want to solve this for t, so I get combining these guys, 6t equals, what's 74 minus 44? Okay, and then division gives me that t equals 5. All right, what can I find pretty easily after that? I can find u really, really easily, right? I can plug u into, I can plug u into this guy right here. So I'll get that u equals 2 times t, which is 5. So u equals 10. And then I can really easily find c using either this equation or this equation. I'm going to use this equation just because it's already set for c equals, right? So my final step is going to be to plug into that equation. I'm going to get that c equals u, which is 10, plus t, which is 5, plus 44. So c equals what? All right. And then I do want you guys to summarize in context of the problem. So what, if you were to write out verbally what each of those mean, what would you say? Okay, what else would you say? What other country can we talk about? Yeah, so the US produced, I'm just going to use quotation marks since I've written it out for the first one. You can kind of do that. US produced how many pounds? 10 pounds or 10 billion pounds. Yeah, make sure you don't forget about that. And finally, Turkey produced 5 billion pounds, right?
Can turkeys even grow?
Apparently. Okay, so that completes that problem. Let's take a look at the next one. All right, so this is an age problem. You're told that the sum of the ages of Olivia, Nate, and John is 49. Olivia's age is 9 less than the sum of John and Nate's ages together. And 4 years ago, Olivia was twice as old as Nate. How old is John now? All right, so the main distinction that you have to make is we're going to use the variables I'm going to use anyway, O, N, and J for Olivia, Nate, and John. The question is, am I talking about their current ages? Am I talking about their ages in the future or the past or what? What am I going to assume those variables are? Current would probably be the easiest, right? Okay, so we're told that right now the sum of Olivia, Nate, and John is 49. So that's a pretty easy setup. You'll just write with addition. Whoa, sorry about that. Did not want to stay highlighted. Okay, we're going to assume that Olivia plus Nate plus John, all of those ages are going to add up to 49. Then I'm told that Olivia's age is 9 less than the sum of John and Nate's. How do I write that? O equals N plus J minus 9. Very good. So you're going to take the sum of the two and then subtract 9 because Olivia should be 9 less than that sum. All right. Okay, now here's where you have to think a little bit. It says 4 years ago, Olivia was twice as old as Nate. What is that going to look like? O minus 4, so Olivia's age 4 years ago, so that's taking her current age minus 4. Make sure that that doesn't look like a 0 minus 4 to you. That is a letter O minus 4. Should equal nope. To N minus 4. You're assuming it was twice as old at that time, right? So if you read that, 4 years ago, Olivia was twice as old as Nate was at that time. So Nate's age, you have to also subtract 4 from his age and then double it. Does that make sense? Okay, that's kind of the tricky part to that is that you guys, it's really easy to not take it off of Nate's age. All right, so now I've got 3 equations. You just go about solving this however you need to. Try and find the most efficient method. The first thing I'm going to do is actually kind of clean up that last equation. So I am going to write this as O minus 4 equals 2N minus 8 so that I don't have any parentheses. All right, where do you guys want to start? So we're no longer using this equation. We've got our 3 equations up there. What is going to be your first step? What do we always do for our first step in a system of 3 equations? Substitution. So we should either have an equation that's already solved for a variable or make one. Do I already have one that's solved for a variable? Yeah. I've got this O, right? So I can take that and plug it into this O and this O. All right, so let's do that. Let's plug it into the top equation. If I plug in for O, I've got that O is n plus j minus 9, so I'm going to plug that in here and then add n plus j equals 49. So that gives me n plus j minus 9, and then finish out what the rest of that top equation was, plus n plus j equals 49. Okay, I don't have anything to distribute into the parentheses, so I can just combine like stuff. I have two n's, I have two j's, and then I'm going to take this 9 and add it over to this 49 so that I'll have 58 on this side. So that's one of my systems of two equations, right? Okay, the next step is going to be to do the same thing for this equation right here. So I'm going to plug in the stuff for O, and then I've got minus 4 equals yada yada. So we're plugging in for that first O, n plus j minus 9, and then finishing out the rest of that red equation. So minus 4 equals 2n minus 8. And now we want to clean that up. So as far as n's go, what I'm going to do is take this 2n and subtract it off of this n. That gives me negative n. Okay, and then I just have the plus 1j. What was that? Negative Nate, yep. I just have this 1j. I have minus 9 minus 4 is negative 13, but I'm going to add it to my negative 8. So what is negative 8 plus 13? Negative 8 plus 13 is positive 5, right? So I've got this and this, which I need to solve. What do you guys want to do? Elimination or substitution? Elimination is probably good. We can multiply this second equation right here. What can we multiply that by? Mm-hmm. What was that? Multiply it by what? Yeah, we can just multiply all of this by 2. Okay, so I'm going to kind of start in some empty space up here. I'm just going to copy down that first equation because I've decided I don't need to change anything on that. So 2n plus 2j equals 58. The second equation we're multiplying by 2, so I'll have negative 2n plus 2j equals 10. That's nice. These eliminate. I get 4j equals 68, or j equals
17.
Very good. Okay, from there, the rest of this should follow pretty quickly. So I know that John is 17 years old, right?
Isn't that all we need, though?
And that's all we need to know, you're right. Very good. So he actually caught, I was about to do more work than I had to. Pay attention, and that's a very good thing to point out. They only asked, how old is John? So we're done, right? All right.